All right, welcome back. Mr. Fransky here again. I'm going to talk to you about section P3 in the calculus book, which is about linear equations and inequalities. In this video, we're just going to focus on linear equations and also ones that involve absolute value. So students will be able to solve linear equations and absolute value equations in one variable. So let's see what kind of vocab we're going to be looking at. So variable, equation, clearing fractions, isolating, and absolute value are going to be the vocab keywords that I'm going to be using today. Let's jump in. So for your bell work, I'd like you guys to do some of the circle work that we had in our last video for P3, and also try solving this guy for x. This isn't something we've explicitly done yet in pre-calc, but it's something you've seen before. So why don't you pause the video and give these a shot. All right, welcome back. So for the first one, we're looking for the center here. Remember, this is really y minus 0 squared. So our center is at negative 3, 0. Remember, this is x minus h. And our radius is the square root of 18. We can simplify that because that's 9 times 2. So that's 3 times the square root of 2. So we have our center and our radius. Now, they want us to write the equation for the circled center at 3 negative pi with radius e. Well, we can do that. It's going to be x minus 3 squared plus y plus pi squared is equal to e squared. That's it. E is Euler's number. We'll be talking about a lot more this year. It's about 2.71. All right, this last one we want to solve for x. So the way I would do this is I'd probably distribute first. So let's do that. So I'd have 4x minus 6 plus 3x plus 3 equal to 5x plus 2. And now let's see what we can do here if we combine a few things together. So 4x plus 3x is 7x. Negative 6 plus 3 is negative 3, equal to 5x plus 2. Now we're at what is often called a two-step equation. We're going to get all the constants on one side, all the x's on the other, and then we'll divide for our last step. So I'm going to get all the x's on one side. I like to keep the x side positive, and that'll be especially important when we get into inequalities. But I'm going to subtract 5x, so I have 2x. Then I'm going to add 3 to both sides. It's equal to 5, so x looks like is 5 halves, or 2.5. That's all there is to it. So you've already done most of what we're going to talk about in this video, which is solving linear equations. So a linear equation in x. A linear equation in x is one that can be written, so it's an equation, which means it has to have an equal sign. An equation that can be written, make sure I use the same letters you have in your book. An equation that can be written ax plus b equals 0. Now, usually they don't come that way, right? But that's the way we want to be able to write it. So like in our last example, starting off, we did not have ax plus b equals 0, but at this point, we could have written 2x minus 5 equals 0. Now, we didn't do that at any point, and often you won't while you're solving, but that's just how they define a linear equation, is that it can be at some point written this way. So notice what we don't have. We don't have any exponents. We don't have any roots. We don't have any logs or anything like that. There's no trig, all right? So no powers is kind of the big thing. It's just a number multiplied by x, and then there might be a constant added, and it's equal to 0. So let's try one. So here we have an equation with a y in it. We're going to try to solve this for y. Why don't you give it a shot? Pause the video for a second and try it on your own. All right, let's see if we get the same thing. And I'm going to show you something that you might not have tried on this problem. So what you might have done, you might have split this up. 5y over 8 minus 2/8, which is, whoops, minus 2/8, which is 1/4, is equal to 2 plus y over 4. And you might have tried to find common denominators to add all this together. I'm going to try this a little bit easier way. I don't like fractions. Actually, I do. That's a little secret of mine. I do like fractions quite a bit, but that's because I'm a math teacher. But if you try this and you don't want to deal with those fractions all the time, watch this. I'm going to multiply both sides by something. So imagine an equation like a scale, right? Or a balance. If you add something to one side or multiply with something on one side, you got to do the same thing to the other side to keep it balanced, right? So I'm going to multiply both sides. What can I multiply by that would get rid of all of the fractions? I think 8 will work. You can always think you're looking really for a least common multiple, and in this case, 8 will work for everything. So here on the left, the 8's just cancel, so I'm left with 5y minus 2. On the right, I have to distribute. So I have 16 plus 8/4, that's 2y. Look how much easier this is. This is so much easier than having to deal with those fractions. So let's see what happens now. So we add 2 to both sides, we have 18. Subtract 2y from both sides is 3y. Y is 6. I didn't have to deal with any fractions aside from multiplying to clear those fractions. That's a technique that's called clearing fractions. So we just cleared the fractions in order to make our lives a little bit easier. Not too bad. All right. Let's try something a little bit more complicated. So equations with absolute value. So the key to this is what I'm going to call isolate the absolute value. So what I mean by that is the way that you solve an absolute value equation is you need to get here. You need to get to the point where you have absolute value of ax plus b is equal to c. If you can't get to this step, then it's going to be very difficult for you. So sometimes there might be like an extra thing, like a plus 5 or something. How do you think we get rid of that plus 5? Yeah, we just subtract it from both sides. So if you can get to this point, then what you're going to do is you're going to split this into two equations. Either ax plus b could be equal to c, or ax plus b could be equal to negative c. I'll show you what I mean. If I have something like absolute value of x plus 5 is equal to 7. Think about it. You guys all know absolute value, what that does is it takes a number and it makes it positive. And really what it does is it tells you the distance that a number is from 0. So in this case, if x plus 5 gave me a 7, then the absolute value of 7 works out just fine, gives me 7. If x plus 5 gives me negative 7, then when I plug it in here, the absolute value will flip it around to a positive, and it'll give me back 7. So that's what's happening right here. I'm saying this ax plus b piece could be the c, and then absolute value will just leave it alone. Or it could be the opposite, and then absolute value will make it positive and solve the equation. So this is kind of what you need, the magic you need to make happen. You need to isolate the absolute value, which is right here, and then we're just going to split it up into two equations, and we'll solve. Okay, so isolation is what we're after. So let's try one together. Let's try this first one. So we have absolute 2x minus 1 equals 7. So like we just said, we're going to split it up. Either 2x plus 1 is equal to 7, or 2x plus 1 is equal to negative 7. Because if that happens, then 2x minus 1 for both of those. There we go. If one of those happens, then this 2x plus 1 minus 1 will either be a positive or negative 7, and the absolute value will take care of it and make it a positive 7. So we're going to solve these separately. So we have 2x minus 1 equals 7. Add 1 to both sides. 2x equals 8. Our answer is x equals 4. The other one, if 2x minus 1 equals... Oh, I did that wrong. I'm going to say I thought the answer was different. Add 1 to both sides. Nope, that was right. My gosh. So 2x equals 8. X is 4. Yep, I like that. Okay. Or 2x minus 1 could be negative 7. Add 1 to both sides. 2x is negative 6. And then we divide by 2. X is negative 3. Now, big mistake that people often make. And this is why I kind of wrote some are tricky. And there's going to be another reason that I wrote that on here in a second. But mainly... is people will get the positive answer, and they'll say it's either 4 or negative 4. Was negative 4 an answer, though? I don't think it was. In fact, if we plug negative 4 in here, we get negative 8 minus 1, which is negative 9. Absolute value of negative 9 is not 7. So that's kind of one of the common mistakes people make. Always, always, always solve two equations. Two equations. Okay? Don't try to take a shortcut, because it'll just open you up to make mistakes. So always split it into two equations and then solve them separately. So isolate the absolutes, split it into two equations, solve them separately. That's all you have to do. Another mistake people often make is they say this absolute value is going to make this a positive. That never happens. The reason you can't do that is because if you flip this, you also have to flip the sign on the 2x. It just complicates your life. Just do it this way. It'll work every time. Split it into two pieces because it could give you positive or negative. Then the absolute will take care of that and give you the positive out. Take a look at b. So for the letter B, you might be tempted to split it off. Z minus 6 could be negative 2, or Z minus 6 equals positive 2. Now, those two will both give you solutions. This would be positive 4. This would be negative 8. But if you plug those in, watch what happens. Negative 8 minus 6 is negative 14. Or sorry, this gives you positive 8. 8 minus 6 is 2. Absolute value of 2 is positive 2. That doesn't work. And over here, this would give us positive 4. 4 minus 6 is negative 2. Absolute value of negative 2 is positive 2. Remember, be smart about these problems, right? They're telling you the absolute value of something is equal to a negative number. That can never happen. So just use your brain before you just start to do algebra, right? We can never have the absolute value of a number be negative, so there's no solution. That's all you have to do. Letter C, we're starting this one with some more complicated algebra, and we have to isolate though. Remember, we're trying to get to that absolute ax plus b equal to c. So let's try this one. I'm going to start by subtracting 4. So I have 2 absolute y over 2 minus 3 is equal to 6y minus 2, just because we subtracted the 4. Now we'll divide both sides by 2. The entire side by 2, right? So we have absolute y over 2 minus 3 equal to 3y minus 1. Now we're at this point. Our c is a little bit more complicated, right? Our c has a 3y and a minus 1, but we're still isolated. We've isolated the absolute value. So what we're going to do now is do the positive and negative. So y over 2 minus 3 could be 3y minus 1, or y over 2 minus 3 could be equal to the opposite of 3y minus 1. So let's solve these out individually. Let's do the left one first. Let's add 1. Let's think about how I want to do this. Let's add 3 to both sides. So we have y over 2 is equal to 3y plus 2. Now we're going to subtract 3y. 3y is 6 halves y, right? 3y is 6 halves. So I'm subtracting 6 halves, so I'll have negative 5 halves y equal to 2. Multiply by negative 2/5 to be able to cancel that out. So we have y equals negative 4/5. A little bit of fraction work there, but not too bad. And over here, let's see what happens. Let's distribute that negative. So we have y over 2 minus 3 equal to negative 3y plus 1. So let's add 3y to both sides. Again, 3y is 6 halves y, plus 1 more is 7 halves y. Add 4 to both sides is equal to, 3 is equal to 4. Step ahead of myself. Multiply by 2/7. Y is 8/7. And there it is. So y could be negative 4/5 or 8/7. You can plug those back into here for the y if you want and see if they work. I'm going to trust my gut and say that it does. All right, that's all I've got for solving linear equations in just regular variables and absolute value. Next up, we're going to have a video on inequalities. So hope you enjoyed that and you learned something new. I'll see you in the next video.